You have another scenario here. We're running a hypothesis test, p equals 0.65, p does not equal 0.65. The sample size is only 58, and we encounter 44 successes. So my statistic, in which case it's going to be p hat, it's going to be 44 out of 58, which is approximately 0.758611. Okay, great. And now I'm just going to keep going through all these, and you can speed me up, and I'll stop talking. Notice I'm using the standard deviation. I'm using SD of p hat. And note that in the previous, when I'm doing confidence interval, what am I using? Well, I cannot use SD of p hat because I'm not supposed to know what this is. So therefore, in this example, I'm using not as the standard error of p hat, an approximation to the standard deviation. And then entering this value, this into GeoGebra to come up with this probability, which is this value right here, or depicted by this area right here. When I have the p-value, because it's a two-sided test, and we're doing only two-sided tests now, we have to double this value. Okay, I did it kind of fast. I'll sped up the video just to save some time, but you can always slow down anytime you want. Also, I encourage you to enter all these values into your calculator, this, just to make sure you're getting those same values. All right, so what's our conclusion? Is the result statistically significant at the mentioned level? What mentioned level? Well, at the 5% significance level. So alpha, my significance level, is 0.05. Is the result statistically significant? The answer is, well, notice our p-value of 0.094. I'm not going to write the whole thing out now. It's definitely not smaller than 0.05. In other words, the rarity is not lower than our output. So maximum rarity is this. And we'll be willing to reject a null hypothesis if my rarity falls to at most 5 or lower. But our rarity is much higher than that. It's about 9%. So result is not statistically significant. There's two parts: statistically significant and significance level. Okay. So statistically significant is about, is this true or not? Significance level is, well, what is that value? Okay. What was the effect size? Here, 44, 58. So this is always a good idea, just to get an idea of how big an effect. And in this case, it's 10%, or a little close to 11%. So it's the difference between the two numbers, our observation and what we think is a true value, is pretty large. But we still failed to reject that, even though it was large. Now we create a 95% confidence interval. And again, why is that? Because we started with 5%, and to make the complement, we do 1 minus 0.05, and we get 0.95. So again, we want these to be complementary if we want the results to be the same. So here, results not statistically significant at 5% significance. So again, we fail to reject, no. So we will continue to believe it's correct. What will the 95% confidence interval do? Well, let's find out. Notice how I'm writing everything that I'm not changing. Write down, write down, write down. And then this is the only thing I'm going to change right now. So I entered this into a calculator to get that value. Again, I'm using Desmos. Multiply these two. This is my standard error. I'm going to do my margin of error. Down the things that are not changing, and now I'll calculate, and I get the following. So this is my value, and it has subtract this amount. When I do that, I get subtract. Add that amount. And now what's happening is I am 95% confident. The true proportion is between 0.6485 and 0.8687. And that's all we're saying with this. That's nothing more to it. I'm 95% confident that the true proportion, whatever it happens to be, is between these two numbers. Does the confidence interval suggest that the null hypothesis is a plausible parameter? Okay, meaning it is one of the parameters. So what was our null here? Well, our null was HO equals P equals 0.65. Is that a plausible parameter? Well, look at that. Our interval is this. So the interval says P equals 0.65 is a plausible value for the population proportion. So in other words, yeah, it's possible. So it fails to reject null at, well, again, if I'm using significance level at the 5% significance level. So that's why we say the two are really that produce the same results. Now, the only slight difference is that the standard error and the standard deviation are slightly off. Okay, they're not the same. I use this value, notice, at 0.75 to use my standard error calculation, while this one uses 0.65 for my standard deviation calculation. So the two are not quite the same, but they're not too far apart. So you would only get into sort of like a potential mismatch if we were right at the edge, very close. But for the most part, that's not going to happen. So they both should agree. And if it's right at the edge, no big deal. That means, again, you're in that zone and you have to kind of interpret that correctly.